In today's video, I'll be going through integration examples. So there's a couple of rules you have to understand, and they are expression dependent. The rule that we'll be looking at in particular is the power rule. So I said in the previous video that an integration is a reverse process of derivation. So basically, before we do power rule, I want you to understand a few things before we actually do that rule. So imagine that you had a function, let's say x to the power 5, and you're asked to find the derivative of this function. So basically, you would do this. The derivative of this function would be 5x to the power 4. Why? Because in general, a function of the form x to the power n would give a derivative using this rule. You take n and put it in front of x to the power n as a coefficient, and then you subtract 1 from n. And n, of course, is a constant. So this is the rule that you use. Power rule in integration is the exact reverse of this method. So this is power rule. Let me show you power rule. In power rule, instead of doing this calculation, what you will do is, if let's say you have this question here and you're asked to integrate, when this is written this way, you are being asked to integrate. So the integration of this would be x to the power of 6 divided by 6. And what we did here was we said x to the power 5 plus 1, and then we divided by the result in the exponent, which was 5 plus 1. You see? So basically the rule is, if you have an expression such that it's like this, the integral of this expression is carried out in this way: x to the power of n. So instead of subtracting as you did there, subtracting 1, you add 1 on the exponent. And instead of multiplying by n as you did here, you divide by n plus 1. You divide by this result here. So that's how you would do, this is how you do power rule. Okay, so let's do another example. Say you have x to the power 4 dx. What's the integration of this? So what you will do is you will have 4 plus 1 divided by 4 plus 1, and that will give you x to the power 5, and then 4 plus 1 is equal to 5. This is going to be 1 over 5 multiplied by x to the power 5. And remember, you need to have a c here, a constant, because you don't know. Suppose, for example, that you knew that an original function you had was, say, 1 over 5x to the power 5 plus 3, and you know that differentiation is the opposite of integration. So when you differentiate this, it would go back to this. So if you differentiate this function, you would get 1 over 5 x multiplied by 5 x to the power 4 plus 0. Basically 5 would cancel 5 and you would have x to the power 4, which is what we started with here. So you can see that when we differentiate this, we get x to the power 4, which we have there, even though we had a constant, right? So when you're performing integration, you have to account for the constant that may have been there. You see, it could have been 3, it could have been 5, it could have been any number. So that's why you have to put a c there, because you're accounting for a potential constant that could have been there. The constant could be 0. C could be 0, but then we don't know that. So there's a range of functions that you could form that have a certain constant, defined constant that we don't know. Okay, feel free to take a few seconds doing this one. So here you still apply the same principle because you have a constant on top, it's still power rule, so you will just have 7 plus 1 and divide by this at the bottom, and then this is going to be 7 plus 1 is equal to 8, so you're going to have 1 over 8, and then x 7 plus 1 is 8, so this is going to be x to the power 8 plus c. And remember, we always add a constant when we are dealing with indefinite integrals. A definite integral would have something like this, say an interval from x is equal to 0 to x is equal to 3, but then we're going to discuss that in subsequent videos. For now, we're still dealing with indefinite integrals. Okay, now we're going to do a slightly unusual example for someone who is doing this topic for the first time. Imagine you had something like this. Let's say you had x over 7 dx, and you're asked to integrate this. This is how you do it. You can just take 1 over 7 out. Remember, this is the same as 1 over 7 multiplied by x dx. So you can take out this constant and put it in front of the integral sign and have x dx here. So what you will end up with is this. The integration of this is still, remember, there is a 1 here, even though it was not written. So 1 plus 1 divided by the result in the exponent plus c will be the result of this expression. So all in all, we will have something like this. 1 plus 1 is 2. 1 plus 1 is 2 there, plus c. I prefer writing c in the last step, but then it doesn't matter as long as your answer is correct. So 2 times 7 is equal to 14 plus c. That's how you would do it. Okay, I like to expose people to as many types of questions as possible so that they are better prepared when it comes to writing their exams. So as we did in the past example, we're going to take 4, the constant, out. We will be left with the function inside. So basically, this is 4 times the integration of x to the power 5. X to the power 5 becomes x plus 1 is equal to 6, plus 1 is equal to 6, and then this will be 4 times x to the power 6 over 6. So 2 goes into 4 twice, 2 goes into 6 3 times. So we're going to have 2 over 3 x to the power 6 plus c. Let's do another example. What if you were given a constant like this? Let's say 8 dx. So what if you were given something like this? How would you integrate this? The rule is still the same, but it wouldn't be immediately noticeable for a person who's not like who hasn't done a lot of examples here. But then let me explain it in a way that's going to be palatable for you. So you know that there is a 1 there, right? Because when you say 8 times 1, you're going to get the same thing. You're going to get 8 there. So what you can do is that you can just manipulate and ask yourself, what exponent should I raise a variable to so that I have 1 here? If the variable would be x to the power 0 dx. And someone might ask, why do we choose x? Basically, you choose the variable that's here. If, for example, in this example, we had something like this, dz, you would then write it this way, 8 z to the power 0 dz. You see, you choose the variable based on what's given next to your d. Yeah. Okay, so let's continue. You take 8 to the left, and you're left with this 8, and then you have a constant. You have a variable raised to a constant. Still, it's power rule, so it's going to be 0 plus 1 divided by 0 plus 1 is equal to 1, so this is 1 here, and the answer will be 8 x plus c. 8 over 1 is 8. X to the power 0 plus 1 is x to the power 1 plus c, and that's your result. How would we do this one? This one is still the same as the previous one, it's just that we have a different variable now. So you would have y to the power 0 instead of x, because you are sort of like the variable that you put here is dictated by the variable you have here in front of t. So this would be 5 y to the power 0, and remember, we say y to the power 0 because we know that y to the power 0 is 1, and 5 times 1 is still the initial expression you're given, so we did not change this expression in any way. So y to the power 0 becomes y to the power 0 plus 1 divided by the exponent 1 and then plus c. So your answer will be 5y plus c. Now let's look at this example. Here we are given a binomial. The integral of a binomial is still rules, but what we simply need to do here is to integrate separately. You'll integrate this variable and integrate this constant. And what you're going to have is, let me show you. You're going to have 5x to the power of 1 plus 1 divided by the result here. That's 2. 1 plus 1 is 2. You divide it by 2 there. And then 2 becomes 2x. Remember, the integral of 2 is equal to 2x to the power 0 dx. And 2x to the power 0 dx becomes x to the power of 0 plus 1 divided by 1, which is 2 to the power x. That's why we have 2 to the power x there. But then you're probably noticing a trend now. If you have the integral of 5 dy, that's going to be 5y. Let's see, of course, if you have the integral of 4 dz, it's going to be 4z. So the integral of this is basically 4 with the variable z. The integral of 5 is 5 with the coefficient, with the variable y. The integral of 3 dm will be, as you can guess it, 3m plus c. So it's basically this number with that m there. That's how you do it. Okay. The final answer will be 5 over 2 x to the power of 2. 1 plus 1 is 2 plus 2x plus c. We don't forget c because this is an indefinite integral. Let's do another example. This one is a trinomial, so you can go ahead and try to do it and write your answer in the comment section. I will do this one because I feel like this one is simple. Okay, now how would we find the integral of a radical function? Here you have to write your radical function in this form. Remember, if this is equal to, remember there's a 2 here, there's a 1 here, and the exponent of x goes on top in the numerator, and 2 that's here in the root goes to the bottom. And if you had let's say 5 and x to the power 3, this would be 3 to the power 5. Basically this goes there and this number goes there. So that's how we got this one. If there's nothing written here, you assume it's 2. So this is easier to work with because it's just a constant on top. You would do this one this way. We have 1 over 2. You would add 1 as usual and divide by the result. Remember, 1 over 2 plus 1 is the same as 2 over 2. So this is 2. 1 plus 2 is equal to 3. So this is 3 over 2. So we just put 3 over 2 here. And then this will become 2 over 3 x to the power of 3 over 2 plus c. When you divide by a fraction, you invert it and multiply with it. So that's how you would do it. Subscribe and recommend this video to others. and watch the next video where I'll be doing more of these questions.